what you guys are going to do today. You may need to take out your multi-step word problem notes to help you with this. You may not need them. But you need to decide, so you're going to babysit, and you're going to decide, would you rather charge $5 for the first hour and $8 for each additional hour, or charge $15 for the first hour and $6 for each additional hour? So however you figure that out, whatever works for you, you figure out which one is better for you and why, and then we'll come back and we'll talk about that in like 5 minutes. Which one did we choose and why? Ashley. Okay, why? So it would be 15 plus this 5 times. Anyone have the same answer for a different reason? The second one, charge 15 for the first hour, $6 for additional hour. What about, did anyone choose the first one? So I saw some different methods. Some were like this, or maybe not like this. Some were, let's say, what is 15 plus 6? Figure out what that is for the first hour, and 5 plus 8, figure out what that is for the first hour, compare. And then add another 8, add another 6, figure out what that is for the second hour. Some of you were doing it like individually like that. I saw some of you come up with some equations. What was that equation for this one? And then there was a similar one for this one. What was that one? I saw some of you use those individually and start putting in different hours, so that would be equivalent to like this process. And then I saw some of you put these equal to each other. And I think when we set them equal to each other, at some point, no matter how many hours or that amount of hours, you would get the same price. I want to say it was 5, but so at 5 hours, it would have been the same either or, but I think as you did more, this one started to get higher, or as you did less, this one got higher, something like that. So it also depends on how long you're babysitting for. If you're not babysitting for a long time, then one might fit your benefits more than others. Were there any other different ways that I didn't talk about? Or any other reasons anyone wants to share? So today we're going to move on. So we've talked about solving multi-step equations and word problems. And today we're going to solve absolute value equations. Solving absolute value equations is very similar to solving multi-step equations, but there's a bit extra in there. I'm going to have you write this stuff down first. as you're writing those down, I'm just going to talk through the steps. So first, you have to make sure the absolute value expression is isolated. What does that mean, the word isolated? Separated, or like by itself. And then we're going to set the inside equal to both the positive and negative number from the other side. I'll talk about what that means here in a moment. Solve both equations, and then we're going to write our final answer in the solution set. So it's going to look like this. So you have this part written down too. X equals curly brackets, the least or smallest number, and then the biggest number. Still need this up. So we're going to start with the very basics, and then as we progress, it'll get gradually harder. So number one, if we're following the steps, we have to make sure the absolute value expression is isolated. So that these bars, there's nothing around it. Well, that's already the case, so we don't have to do that part check. Then we have to take what's on the inside, drop the absolute value bars, and set it equal to a positive version of this 2 and a negative version. Remember that absolute value measures distance. So while it can be positive, it can also be a negative. So that's why we set it equal to both. And then if these were equations, we would solve them, but they're done. So then we can write this as a solution set. So in curly brackets, least to greatest, -2 and then 2. When you have the same number, but one is positive, one is negative, you can also write it like this. Plus or minus is the name of the symbol 2. It just means negative and positive 2, instead of writing them out separately. Do we have questions on that one before we move on? Let's try number 3. So same thing, make sure this is isolated, there's nothing around it, which is the case, so check on that. Drop the absolute value bar, set the inside equal to a positive 40 and a negative 40. So if you don't set it equal to the negative number, you're going to miss half of the work and half of your answer. So make sure you set it equal to both. And then solve. So we can divide both of these by 5. So that z equals 8 and -8. So you can put it as plus or minus 8, or you can separate it. All of your problems won't have the same 2 numbers, but some of them will. It just depends on the problem. Do you have any questions on that one before we continue? Okay, let's try number 5. Same as before, make sure the absolute value is isolated, there's nothing outside of it, so check on that part. Drop the absolute value, set the inside equal to the positive 8 and a negative 8. And then to get d by itself, what would you do? Subtract 1 on both sides to both equations. So this would be a case where the numbers are not the same, and that's okay. So then least to greatest in curly brackets, -9 and then 7. Here we could not put plus or minus because the numbers are not the same. questions, concerns about that one? Let's try another. I'll let you guys choose 7 or 8. 8. Sure. Okay, so for 8, make sure the absolute value is isolated. Drop the absolute value bars. Take what's inside, set it equal to 17. Also set it equal to a negative 17. And then start to solve this. What would be our first step? Add 5. So we have 22 and negative 2b equals negative 12. Divide on both sides. So then we get negative 11 and 6. So we would write that as a solution set. B equals, in curly brackets, negative 11, 6. Have any questions on that one or any problems we skipped over on this page before we move on? That's a great question. So with these absolute value bars, because we were trying to find the solutions, what's on the inside does not become positive because we were trying to solve for it. Also, we've gotten rid of the absolute value bars, so nothing would change. So for these, you should not be changing negatives to positives except right here. That's it. Any other questions for this page? Or any other problem we skipped over that we want to go back and do? If not, go on to the next page. Okay, so all the problems we just did had nothing outside of the absolute value bar, so we didn't have to isolate it. But now we do. So we're going to isolate the absolute value bars. So let's try number 9. When we isolate the absolute value bars, we have to think about whatever's inside the absolute value bar. We don't touch that. We leave that alone. That's like our X we're trying to solve for. We get rid of everything else on the outside like we would solve a normal problem. So how would we get rid of this 2? Subtract. Once your absolute value bars are isolated, then we solve it just like we were doing before. Drop the absolute value, set it equal to a positive, negative, solve if necessary, write as your solution set. So this would be plus or minus. Let's try 11. Again, we're isolating the absolute value bars. We gotta get rid of that 6. What would we do there? So these two are multiplying, so not subtract. So how do we undo multiplication? Divide. Alright, and then just like before, drop the absolute value, set it equal to a positive and negative 4. Write your solution set. 2. And now that it's isolated, we can drop the absolute value bars, set it equal to a positive 7 and a negative 7. And then start to solve. So to solve this, we would do what? Three on all sides. So then our two answers, we would get z equals, in curly brackets, negative 10, positive 4. Have any questions so far on the process, how we're getting the answer, anything like that? Let's try 13. How would we get that isolated? Multiply by 6 on both sides. We gotta get rid of that 6, and the only way to do that is to multiply. We have absolute value of 2w minus 4 equals 18. What's our next step? We will eventually add, but we have to drop the absolute value bars and make sure it's equal to a positive and negative 18. So if you just start adding from this point, you've skipped a couple steps. You have to make sure we isolate it before we start solving, and we can't solve while it still has absolute value. But yes, we would add 4. We have 2w equals 22 and 2w equals negative 14. Divide everything by 2. W equals 11 and negative 7. I'm going to write that over here. Questions on that one?
So you don't make the negative 4 a plus 4?
No. We do not change anything that's in here. The only thing we're changing is this. Making it a positive, negative, after you drop the absolute value. I know it's different from what we were doing with the absolute value with evaluating, but we have to change our mindsets on this one. Do not do that at all. It will change your problem. We don't want that. Let's try 14. What do you think we would do first on that one? Get rid of anything you can add or subtract first. We have negative 10 times the absolute value of h plus 5 equals negative 80. And then divide both sides by negative 10. And now that it's isolated, what's our next step? And set it equal to a positive and negative 8. Subtract 5 to everything. So that we have 3 and negative 13. I'm going to write that again over here. Any questions about that process, how we got those answers? I'm going to have you try a couple, then we'll come back and talk about it, and then we'll talk about some special case ones. So I want you to try 15 and 16, and I'll give you some time to do that. As you're working through it, check with the people around you, see are they doing it the same way, did they get the same answer. If you need help or have questions, raise your hand and I'll come around. We'll come up and one do 15, one do 16, you guys can choose. Sonny, you can choose the first one, then Lily can do the second one. I don't know if you guys can do this at the same time. Just make sure your paper doesn't touch the board because it's sensitive. If you want to change the business, you can. And this one, yep. Because I can't type in the password she's right. Quickly, and then Lily, you can go ahead. Lily, you can go ahead and do 16. Okay. Just equal signs in here. Who all got that answer, negative 6, 2 for that one? Good. That was the correct answer for that one. If you want to change the thickness, I'm going to just tap the top. That happens sometimes. I don't call it the ghost of the smart board. I don't know what's going on with that. Alright, so I saw different answers, either 1/2 and 3/2, or 0.5 and 1.5. Either or was fine for this one. But who else got that as an answer? If you didn't, go back and fix it. Did anyone not get that answer that isn't sure where they went wrong? They have questions.
It's okay to use decimals.
Yes. So if you use 0.5 and 1.5, that was fine. Is that what you got? Okay. That's great. When you're doing this, you do need your solution set, but you also need to solve these. So make sure you have whatever equals whatever before you put it in your solution set. I think those were the only things. Any other questions about these? Let's talk about some special cases. So if you see, you isolate the absolute value bars and you get a negative, you cannot solve this because it has no distance, so it can't be negative until we go to solve it and we drop the absolute value bar. So this would be no solution. Sometimes you won't see that it's no solution until you start to solve it, until you start to isolate it. So here, when I go to divide both sides by -3, I have absolute value of 2x plus 1 equals -7. But now my absolute value is isolated and it equals a negative, so I cannot solve it at that point. It's no solution. This symbol also means no solution. See?
What happens if you try to solve it?
Say that one more time.
What happens if you try to solve it?
You theoretically you can solve it, like you could physically keep going, but it wouldn't be correct. I'm going to show you what happens in Desmos, like if you were to get a no solution. If you were to keep solving, you have now made up answers that don't exist. Is really what you do. So I'm going to show you what happens in Desmos after I put this explanation. I'm also going to go back to a couple of these just to clarify some things. So we had a negative, but as we were solving, it went away. So then we could keep going. Same thing with 14. You had a negative, but when we divided, it went away. So then we could keep going. And then in 12, same thing. We had a negative, but then it went away. The explanation for that is this. Right, this is just the rule. Absolute value cannot equal a negative number once it's isolated. This would give you what you'll learn later is called an extraneous solution. It doesn't. It wouldn't work. So a couple ways to check yourself. One is in Desmos, which I'm about to show you. One is in the calculator. Just like when you check yourself with your multi-step, you put the number in, you set it equal to both sides, and you see does it work, does it give you the 1 or the 0. You could do that with your calculator. So let's say you were to solve one that ended up being a negative and you put in these numbers, it's going to give you 0 every time. You're going to keep fixing it, and it's going to keep giving you 0 every time on the calculator. On Desmos, this is what happens. Skip this. So I'm going to put in just a random one. Let's say I put in this one. -10 times absolute value of h plus 5 minus 3 equals -83. When you put this into Desmos, you have to have x's, not anything else. I already forgot what I just said. What was the rest of that? The one that had equals -83. I don't remember what this was right there. Alright, so So just like with your multi-step, it's going to have 2 lines for you. It's not going to tell you what they are, so if you're zoomed out, you may need to zoom in to figure out, okay, that's 3, that's negative 13, but you can still figure that out. But if I had something like, I'm just going to make up a random one, x equals negative 10. You're not going to see lines. Nothing will appear because it's no solution. Thank you. So if you see that it's not a typo, there just isn't a solution. Nothing that will make this a true statement. Right? On the last page, there are some problems I want you to practice. You can use your notes, each other, your calculator does those, but make sure you're showing your work. So on this page, I want you to try numbers 2 and 7. You can circle those, star them. On the back page, so 2 and 7 on this page, 9, and then 13 through 16. So 2, 7, 9, 13 through 16. Raise your hand when you finish and I'll check them. You have this time.